Hello everyone. This video illustrates how the District Lab H Simulation Studio software can be used to analyze the operation of a district heating network at a village or neighborhood scale. We'll take a look at a study carried out for the commune of Feurs in central France. The first step is to open an existing model representing a system consisting of a single production site, supplying 3 feeders and connecting a dozen consumers. In terms of modeling, the production site is represented by an equivalent pumping station and equivalent generator. We'll see later in this video how to refine this representation. For now, let's switch to post-processing mode so that we can run a simulation. To do this, we first need to parameterize the simulation case. This is done via a dedicated graphical interface. Start and end dates must be chosen, which in this example are set to January 1st and 31st respectively, so as to represent system operation over an entire month. To enrich the simulation results, we declare additional post-processing variables called UDV for user-defined variables. These enrich the results natively presented by District Lab H. The UDV allow us to represent a generator cascade made up of 3 generators: biomass 1, biomass 2, and a gas generator used for peak load. This cascade is operated according to a logic that can be programmed via a user-editable script. The next step is to check the simulation case, then run the simulation. The progress of the calculation is shown by a progress bar, and at the end of the calculation, the results file is automatically loaded into the graphical interface. Pre-configured curves are displayed to provide an overview of the simulation period under analysis. The top curve shows the evolution of the outdoor temperature, with a cold period featuring temperatures approaching -10 degrees Celsius at the end of the month. The second curve shows the evolution of power generated, called, and delivered, the latter 2 quantities being equivalent in this case. The third graph shows the evolution of minimum and maximum consumers valve opening. Finally, the last curve shows the stacked output of biomass generators, 1, 2, and the gas generator, which comes on when the capacities of the other generators are no longer sufficient. Returning to the map view, it is interesting to highlight the power reserves in the network piping. The color coding reveals reserves of the order of megawatts near the production plant. This can be interpreted either as oversizing or as a desire to retain room to connect other users at a later date. The software also features a dashboard function, which summarizes a number of technical, energy, and economic indicators. For example, energy called and energy produced over the period. The difference between the two obviously stemming from energy losses or integrated pumping energy over the month and production costs for the various generators. In short, this video illustrates some of the potential offered by District Lab software for designing and evaluating small-scale networks, which are set to grow significantly in France and Europe over the coming years. Thank you for your attention.